killer cannibal robot? Yes. Now check this out. Robots that eat to evolve. Columbia University just unleashed a whole new era of AI-driven machines. What if robots could grow, heal, and even feed on other robots to get stronger? That's not sci-fi anymore. Columbia University just introduced robot metabolism, and it's going to blow your mind. Let's break down this breakthrough that merges biology, robotics, and AI in a way we've never seen before. So what is a robot metabolism? Traditional robots are closed systems. They're pre-built and pre-programmed. If they break, a human must fix them. Columbia's new system is open, self-sustaining machines. The core unit is called a truss link, a smart modular bar that can expand, contract, and attach magnetically. Alone, a truss link just crawls, but combine them, they build shapes, structures, and even new robots. Growth, healing, and cannibalism. 6 truss links formed a triangle starred diamond with a tail, also known as a tetrahedron. That tetrahedron found another truss, integrated it into its body, and became ratchet tetrahedron. The result? 66% faster movement downhill. These bots don't just crawl, they heal. Drop them, they shatter. Then they reform and keep crawling. One even simulated cell death. A drained battery shut down, replaced with a new part like an organ transplant. This is seriously cool. You can see these things coming to the battlefield. Robots helping robots grow. Tetrahedron bot used one limb like a crane, lifting up a 2D shape and birthing a new 3D robot. These bots don't just evolve, they replicate and assist others in evolving, so they're collaborative. Yeah, this sounds like the start of a sci-fi movie, but it's real and it's just getting started. So why is this a big deal? These bots are designed to mimic biological modularity, like amino acids forming life. Each truss link has its own microcontroller, actuators, Wi-Fi, and lithium battery. They're still expensive right now because they're made so slowly. Each truss is $200 a unit, but they're deliberately simple and reproducible. And yes, this can scale. So what about real-world testing and performance? They tested it in a 13-foot obstacle zone with ramps, drops, and uneven terrain. They also tested real versus simulated movement. For a triangle, it's great in simulation, but bad in real life. The tetrahedron is most consistent. The ratchet tetrahedron is the fastest, but it's also unstable. They did 2,000 simulation runs, which showed some shapes are rare without guided environments. Context matters. So these things do need some guidance, at least now, on how to properly assemble themselves. So what's the future vision here? Autonomous self-sustaining machines. Lead researcher Hod Lipson. AI brains are evolving rapidly. Bodies' hardware are not. For robots to thrive in space, disaster zones, deep sea, or industrial roles, and I would add military to that, they need physical autonomy. Future upgrades may include sensors like IMU, cameras, or magnetometers, so these bots can see, decide, and evolve on their own. They may eventually form ecosystems of autonomous, repairable machines. So what's the wrap up? This isn't just AI, this is an evolution in robotics, and I think a pretty big evolution. It's modular, self-repairing, self-growing, and maybe one day self-aware. Can you say Terminator? We're not just building robots, we're engineering life in mechanical form, said Columbia. So what do you think about this breakthrough? It's a pretty big breakthrough, just like the very last video I did. Let me know what you think. Drop the comments below. Also, please like, subscribe, and share this video. That'll really help out with the algorithm. And finally, please consider supporting us on Patreon. We need your support to be able to continue to grow the channel and bring you cutting-edge stories, resources to help you navigate the tsunami of automation that's here now, and even tools. We can do all that with your support. So thanks so much. We'll see you next time. Take care.